So we're going to talk about science as a discipline and some of the general concepts that are really foundational to biology, chemistry, physics, all of the natural sciences, regardless of the specialty that might be involved. So one of these fundamental concepts is this idea of hypothesis, of forming hypotheses and making theories. And so I want to really spend a little bit of time defining these terms. So a hypothesis is a proposal that explains something in the natural world. And a hypothesis is very, very specific. So when we're making hypotheses in the classroom, I'm going to always ask you to be very specific, to choose one thing. So if you want to explain something in the natural world, it might have several components to it. But in a hypothesis, you've got to pick one thing because you're going to be testing that hypothesis. And so the limitations of experiments is that you can only test one thing at a time. So again, it must be a very specific explanation. The other term that's often used for hypothesis, and again, one you may have heard of it before, is an educated guess. I don't really like the guess part because you're not just throwing out some random guess. And so really the most important part of it is the educated part. And the educated part can come from something you read, a book, an article, something somebody told you, or it oftentimes comes from observations that someone else made or that you made yourself. And so that's the getting educated to come up with your explanation. So really maybe better than educated guess, we could say an educated proposal to explain a natural phenomenon. And so again, just to come back to this idea of being specific, a hypothesis needs to be specific enough that you can make predictions. And so the predictions need to be about an experiment you could do. We're going to walk through some examples of this. So if you're kind of feeling a little nervous about this, don't worry, we're going to look at a lot of examples. And so the reason why we need a prediction is because that's the only way we can test it and show whether our hypothesis appears to be correct or appears to be incorrect. And so that experiment will lead us to being able to say, okay, yes, our prediction matched our experiment, and so it supports our hypothesis, or it did not match our prediction, and therefore we need to reject our hypothesis. So notice these terms, support or reject, accept or reject. What we don't like to say in science is that a hypothesis is proven. So don't use that word in biology class. I'm going to cross it out if you write it in your labs because we don't prove things in biology. We support them. And this is a really important mindset in biology, to not prove things, but to support them. This keeps us open-minded to revising what we used to think. A theory, in some ways, is similar to a hypothesis because it is an explanation for things that we see in the natural world. But notice I use here in the definition the word broad, not specific. So it's a broad explanation that describes phenomena in the natural world. But it is so broad that there is a large amount of evidence that now supports that theory. And so we could also say that a theory is really supported by a bunch of different hypotheses that have been tested. So a theory is so broad that you can make many different hypotheses, make many different predictions. Each of those predictions can be tested. And in order for it to become a theory in science, each one of those predictions needs to have been supported. So hundreds and hundreds of different experiments have been done, and all of the experiments have supported this explanation. And then in science, it will become a theory. But again, notice that we don't prove them. They're never absolutely true. But because they've been so well tested over long time, we believe that they're extremely likely to be true. Everything that we're going to be studying in this class, pretty much the whole semester, even though we're not going to use the word theory, is a theory. Everything. Large amount of evidence supports it as the whys and hows of our bodies or our cells, but it's not proven. It's a theory. So, and one that I'm sure you're very comfortable with is that DNA is the genetic material. People go to jail based on DNA being the genetic material. People are executed in this country. based on DNA being the genetic material. But in science, that is a theory. It's a theory that it's the genetic material. So again, you know, in our everyday life, we think theory means that there's a lot of uncertainty. But in science, it's the opposite. Theory is the most certainty that we have in science. So science, as I said, we don't prove things. We substantiate or support them based on evidence. And like I said earlier, this is really a mindset about being open to changing what we used to think. And so I like to give this example because just to give you an idea of how much science is constantly revising our ideas. This is from my textbook when I was in college, my Bio 111 textbook. And it's about taxonomy that we talked about earlier. And I just want to point out to you that the three-domain system that you see presented in your textbook was a brand new theory when I was in college. And in fact, at that time, they were still presenting these other systems, the 6 kino system. You don't need to worry about the details or anything, but the point being that, whoops, sorry about that. The point being that in just these 15 years, there's been this changing ideas in science because there was new experimental evidence. So new experimental evidence demonstrated that, hey, what we used to think actually isn't true, and we need to revise it. And when we have an open mind by not proving things, that keeps us more open to this possibility of change. I mean, to give you an example that's a little more closer to home, you're probably familiar with this idea of trans fat being bad for you. It's on all kinds of food labels and ads now. But 10 years ago, people thought that trans fat was better for you than just plain old, you know, saturated fat from a cow. So this was the butter versus margarine debate, really. So for a very long time, everyone thought margarine was better for you because it didn't have animal fat in it. And butter was bad for you because it did have animal fat. But what they realized was when they looked at evidence, or then they looked at experimental evidence, in fact, margarine was actually being bad for people, and what that eventually led them to was realizing that the trans fat that was in margarine was really bad for people. And my point being here that scientists had to be open to the idea that what they used to think wasn't actually true in order for that to be discovered. Because if we just closed the book on it, we would never keep doing experiments on a subject. By saying it's supported but not proven, we're always doing new experiments. And so that's the mindset of science. And I really want you over the course of the semester to keep that mindset in mind as we're doing labs. You're not proving things, you're supporting them. And so you should always be questioning whether that your data actually makes sense, and what would be the next sort of experiment you would want to do to keep supporting your hypothesis.